Can specific phenomena affect Aurora Borealis intensity? Imagine looking up at the night sky and witnessing the shimmering dance of lights known as the Aurora Borealis. Did you know that certain natural events and conditions can make these lights brighter or more vivid? It's true. The main factor behind the strength of these displays is solar activity, which follows in roughly 11-year cycle. During the peak of this cycle, called solar maximum, the sun produces more sunspots, small dark patches with intense magnetic activity. These spots lead to increased solar wind, which is a flow of charged particles heading toward Earth. When more particles reach our planet, the auroras tend to be brighter and appear more often. Two key solar phenomena influence the intensity of the aurora. The first is coronal mass ejections. These are huge bursts of plasma that shoot out from the sun at very high speeds. When a coronal mass ejection hits Earth's magnetic field, it can cause powerful geomagnetic storms. These storms can make the aurora visible much farther from the poles, sometimes even in parts of the northern United States. The second phenomenon is coronal holes. These are areas on the sun with open magnetic field lines that allow high-speed solar wind streams to escape. When these streams arrive at Earth, they cause moderate geomagnetic storms, which can lead to active auroras, but usually not as intense as those caused by coronal mass ejections. Geomagnetic storms happen when the solar wind disturbances interact strongly with Earth's magnetosphere, the magnetic shield around our planet. If the interplanetary magnetic field points southward, it lines up with Earth's magnetic field, allowing more solar wind energy to enter. This energizes electrons that then collide with gases in our atmosphere, creating the colorful lights of the aurora. The strength of these storms is measured by the KP index, which ranges from 0 to 9. When the KP index is high, the auroras are brighter and can be seen over larger areas, sometimes even in southern parts of Canada or the northern United States. Seasonal and daily changes also play a part. Auroras tend to be more active around the equinoxes, which are in March and September. This might be because of how Earth's tilt and the sun's magnetic field interact, making it easier for solar wind to energize the magnetosphere during those times. So, in short, the intensity of the Aurora Borealis depends on solar activity, specific solar events like coronal mass ejections and coronal holes, the strength of geomagnetic storms, and how Earth's magnetic field lines are aligned at any given moment. All these factors come together to create the stunning light shows that make polar skies so mesmerizing. Did you know? The colors you see in the aurora depend on which gases in Earth's atmosphere the charged particles hit. Oxygen produces green and red lights at different heights, while nitrogen can create blue or purple hues, adding to the wonder of these natural wonders.